How's everybody doing out there? Well, welcome to day 4 of Corona Online School. Hopefully, everybody's not frustrated after assignment 2 that we worked on last time. So, I think some people get some good stuff. It was definitely a little tougher trying to do not in the classroom, but I thought it was a good experience for you guys to try to do it with just the minimal definitions that were given instead of having kind of the full blown definitions and stuff like that. Well, hopefully, in the meantime, you've had a chance to go through the packet, go through the definitions. If you have any questions or anything like that, or if there's any definitions you don't understand, just let me know. But I thought we'd kind of work through, go back to 2.1 real quick before we move on, just to make sure I'd put these down as practice. I don't know if people had a chance to look at them or not, but I thought I'd kind of walk through how to do these, talk a little bit about them, just to make sure we're on the right track. Because if we don't have this stuff down, we might as well kind of wait on 2.2 a little bit. So let's check this out first just to see how everybody's doing. So practice 1 was talking about relating back to the word description, brace notation, and set builder notation and trying to write it into a different form. So in this case, the only two that we're focusing on is either the word or the brace. And they're telling us up front that our universal set contains all even numbers up to 30. Is what that is? And so part A gives us the set of even whole numbers greater than 12 and less than 16. So in this case, hopefully we can recognize right away that this is a word description. And so what we want to do is we want to write this then in brace notation. So what we're going to do is we're going to put our little curly braces in there, and then we're looking for numbers that are bigger than 12 and less than 16. So the question is, should I start with that number there? So hopefully everybody at home is yelling out, no, don't start with that number. You're right, because since it's strictly greater than, that means we don't want to actually include 12 in our list. So in this case, let's get rid of 12. So we want to start with the next even number after 12, which would be 14. And then we also want this to be less than 16. So are we going to put 16 in there? No. So again, we want it to be less than 16. So in this case, it turns out there's only one number actually in our set. So it's just the number 14 in that case. All right. Does anybody have any questions or anything about that? All right. So for part B, what they've done is they've given it to us in the brace notation. And so again, what we've got is we've got 22, 24, 26, 28, 30. And so we want to write it using kind of similar wording to part A. So what I'd probably do is write this almost the same. So the set of even whole numbers. Now this is up to you. So if you want to do like they did here and use greater than, then what we'd want to do is we'd want to use the number 20. Or you could just do greater than or equal to, and then that would allow us to actually include the 22. So for me, I'm going to do greater than or equal to. So the set of even whole numbers greater than or equal to 22 and less than or equal to 30. So again, depending on how you wanted to write this, so like you could have said less than 32, greater than 20. Either way is fine with me. So I like using the equals sign, but it's up to you. All right. Does that make sense? Everybody good with that? All right, very good. All right, so let's take a look at practice 2. So this is a nice one for practicing trying to fill in a Venn diagram. So we did this with the circles and stuff like that on the computer, but the one thing we had to be careful of is the computer wouldn't allow us to get it wrong. Like we couldn't put stuff in the wrong spot, where here, obviously, we have to be careful and we may end up putting stuff in the wrong spot. So again, first thing we want to notice is our universal set are all the letters A through K. And then we've got sets that are broken down, A, B, C, and D over here, or A, B, and C. that are broken down. And so we want to plug these guys into the right position. So the main thing when you're doing these is you want to kind of always look ahead and make sure, like, because I don't want to just do this and throw A, B, C, D, say right there, because they could happen to occur in like sets B and C and stuff like that. So I've got to make sure I put them in the right spots. Our Venn diagram has all these little spots, so we want to make sure we put them all into the right spots and stuff like that. So in this case, as I'm looking at A, I'm also going to look over at set B, and I'm going to look over at set C and see if A occurs in any of those other sets as I'm going through. So in this case, it looks like A only occurs in set A. So I'm going to put it over on the left, kind of as far away from the other circles as I can get. And then I'm going to scratch it off just to make sure, like, don't forget anything as I'm going along. And I'm going to scratch it off the universal set too, just to make sure it's gone as well. So now if I look at B, I see that the element B is in set A and it's in the set B. So what that means is I need to put it in a place that's where A and B have an overlap. So do I want to stick it down here? No, because that's also part of C in that case. So I don't want to stick it in that part of the overlap. So I want to stick it up here in this part that's just in A and B in this case. So again, let's scratch off B everywhere. And then we just keep going. So C is in A, it's in B, it's in C. So this one will go down where I kind of jokingly put that first B. So it's going to go where all three circles have that common spot. So again, scratch off C. Then I've got D. So D looks like it's in A and it's in C both. So in this case, I want to look for where A and C intersect. So again, A and C intersect here, but so does B. So I don't want to put it there. I want to put it in this section where just A and C are in common. So scratch off the D. So the good thing is we're done with set A now. We don't have to worry about that anymore. So we can kind of get rid of it altogether. So E was the next thing on our list. So again, it's only in B. So let's put it way over here off to the right so it's not near any other circles. F is just in C, so let's put F way down here in the bottom right corner. So again, it's not near anything else. So that gets rid of F. So if I notice, G is not anywhere in B or C, so that means G has to go outside the circle. So I'm just going to stick G over here to the outside. Now H is in both B and C, so that means I want to put it where they have in common. So that's going to give us H in that spot. And then let me scratch off H. So I is only in B. So again, let's kind of put it over here by E so it's out of the way. J is only in C, so let's put it down here. And then finally, K isn't in A, B, or C. So just like G, it has to go, whoops, what in the world did I do? It has to go to the outside. So that's what our filled in diagram should look like in this part. So we've got things just in A, we've got things just in B, we've got things just in C, and then we've got some overlapping stuff in the middle. So if you did this on your own and you managed to get this exact same answer, good for you. If you didn't do this on your own and you're looking at this for the first time, let me know if you have any questions. Let me know if this makes sense or anything like that. And if so, what we're going to do is just kind of keep using this to answer some more questions about these guys. So let's look at practice 3 real quick. So practice 3 is saying list the elements that are in the following sets from above. So A intersect B intersect C. So in this case, we're looking for where A, B, and C all are in common. So in this case, what we're looking at is this little section here. So where all three circles actually intersect. So in this case, we only have one element that's in there, just element C. So let's write this as A intersect B intersect C is just the element C in that case. All right. Is that okay with everybody? All right. So now let's look at A intersect B. So A intersect B is again going to be just the stuff that A and B have in common. So in this case, it's going to be this part. So A intersect B is going to be that little football shaped shape up in the top. And so it looks like it contains just B and C. All right, so now we're looking at B complement. So if you remember from what we did before, B complement is going to be everything that's not in B. So if you were to like go back up here and look at what B looked like, we know B contains B, C, E, H, and I. So B complement is going to contain all the letters that aren't in that list. So that's one way you could actually do it when you have a list like this. Instead of actually drawing it out, you could just write down, oh, well, let's see. I know A is in the universal set. So A is going to be in B complement. B and C are in B, so they can't be in there. So D's not in there, so let's add D to the list. E's in there, so we can't have it. F isn't in the list, so let's add F. G's not in the list, so let's add G. H is in there, so we can't have H. Let's see. I is in there, so we can't have I. So J is not in B, so J would go here. And then finally, K. So again, if you've got a list, that's one way that you can actually do it. You can kind of work through the list and figure out what's available. Otherwise, if you were to shade it, what this would actually look like. So let me erase these guys since we're done. Oh, I didn't mean to erase the B. So if we were to shade this guy, B complement would look like all this stuff kind of out here, including A, all this stuff in C. And so we can see the only thing that's not shaded is that B, C, E, I, and H. So anything that's in the shaded area, so you see we've got our A, we've got our D, we've got our F, we've got our G somewhere, we've got our J, we've got our K. So everything looks covered in that case. All right, so let me see if I can actually erase this without erasing all the other good stuff here. This could be bad. Ooh, I'm doing pretty good. Look at that, the beauty of technology. So, all right, so let's look at the next one here. So A union C. So again, if we were going to shade A union C, or at least highlight it, highlighting it, it's going to look like, so let's use pink. So it's going to be all the stuff in here, plus all the stuff in there. So anything that's in that big pink kind of weird looking H shape is going to be in our A union C. So I can see I've got A is in there, B is in there, C is in there, D, F, H, and J. All right. So now, let me erase that real quick, hopefully without wiping stuff out. Good. So now let's look at the next one here. So let's do a different color. Let's try, let's see, did I do orange yet? I did orange, I think. Let's see, let's do yellow, see if it shows up. So A intersect B union C. So in this case, with that parenthesis, you almost want to think of this as like an order of operations, which I know we haven't talked about in this class yet, but hopefully you've heard it before. So we want to do things in parentheses first, and then the union, we're going to add stuff to it. So the big thing to remember, intersections make things small, unions make things big. So A intersect B is just going to be the part that A and B have in common. And so we did that above. We saw that that was just B and C. So in this case, here's what the union, or the intersection of A and B look like, which again we saw before. But now what we're going to do is we're going to union C. So we're going to add C to this. So that means I want to shade the outside of C also, so we can include that. So anything that's in that yellow is going to be part of A intersect B union C. So I'm going to get the B, I'm going to get the C, the D, the F, the H, and the J. So let's write that down. So B, C, D, F, H, J. And so finally, last one of these at the moment. So let me try to erase this again without wiping out everything. Good. So let's try a different color here. Let's see. I use that color? Well, we'll find out. So in this case, we've got A complement intersect B intersect C. So in this case, what we do, since there's no parentheses, we're just going to work left to right as we go along, trying to figure out what these guys will look like. So A complement, remember, is going to be everything that's not in A, but since we're intersecting that with B, then it turns out it's just going to look like that. So because that's kind of the nice thing with an intersection, it allows you to shrink it down and make it into a lot smaller set. So now that shaded part, this is going to be our A complement intersect B. And now to that, what we want to do is shrink it down even further, because now we want to intersect that with C. So in this case, that means that what we're looking at is just, I'm trying to make it even bigger and squigglier, just that part. So in this case, E and I, all those things, since they're just in B but not in C, they won't count. So it turns out in this case, there's only one element that lives in this set, and it's just the H in that case. So again, if you did this on your own and you got all these answers right, good job, way to go, very proud of you. If you didn't, if this is the first time you're looking at it, hopefully it makes sense, and if it doesn't, let me know tomorrow so I can help you with these guys. So otherwise, let's look at the last one here. So in this case, we're trying to find the cardinality, so which is another word for the number of elements in the set. So what we want to do is just kind of count how many elements are up in each of these sets and then go from there. So let me erase this little thing I drew here in case we need it. All right. So first thing it says is what's the number of elements in the universal set? So in the universal set, we can just go back up to the very beginning, or you can count all the different letters that are inside, either way. So in this case, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we had 11 elements in the universal set. So in this case, we just write the number 11. So that's it. So the number of elements in A intersect C. So again, if we were to look at what A intersect C is, it's just going to be this part that A and C have in common. So the elements that are in there are C and D, but all we want to know is just the number. So in this case, we just say 2. All right. So now, let me erase this real quick. So now we want to know the number of elements in C complement. So again, we could actually kind of work this backwards by using, instead of the drawing, go to this list. And so we notice that we've got 1, 2, 3, 4, 5 elements in C, but we have 11 elements total. So if we subtract 11 minus 5, then that means there must be 6 elements that do not live in C. And we can verify this by just kind of counting. So we've got 1, 2, 3, 4, 5, 6. So you can do it that way too. So again, just ignore everything that's in C, count all the things that are outside of C. Again, we're not trying to list them, we just want to know the number. So in this case, the number of elements in C complement would be 6. All right, so the number of elements at A union B union C, so that's going to be everything that's inside the circles. So again, we don't want to count G and K. Those are really the only two that we're not going to count. So again, we could do this kind of backwards. We could say, okay, well, there's 2 that we're not going to count. There's 11 total. So that tells us that there's 9 in there. Or again, we could go and count and say 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, however you guys want to do these, you'll get the same answers either way. But it appears there's 9 elements that are in A, B, and C at the same time. So we get a little 9 there. And then A complement union B. So in this case, let's take a look at that. So A complement, let me erase some stuff here. Let's erase this over here. So again, A complement, if you remember, is going to be everything outside of A. So let me just shade that little bit in real quick. Or maybe use the highlighter, maybe that'll be better. Yeah, there we go. So in this case, we're going to shade everything outside of A. I should have been using this whole highlighter the whole time. What was I thinking? This is perfect. So that's A union B. Ignore that little teeny weeny bit that kind of went over there. But then, or that was A complement. But then what we're doing is we're adding B to it. So that means we're adding more stuff in. So even though like this B and C wasn't in, is in A, we still want to add it in because it's part of B in this case. So now everything in yellow is A complement union B. So in this case, again, we're only missing 2 elements. A and D are the only 2 elements that aren't in the set. So that means we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, we've got 9 elements that are living in our set. And then finally, the last thing is the empty set. So remember, the empty set's the set that contains no elements whatsoever. So the cardinality of the empty set is always 0. So no matter what the set looks like or anything like that. So again, if you did these already and you got all these answers, awesome job, way to go. If you didn't do these before and this is the first time you're seeing it, let me know if you have any questions or anything like that. So hopefully this helps make the assignment a little bit better. So if you didn't actually finish the assignment too, hopefully this will actually help make it a little bit better. You can work on that and try to get that done. Otherwise, we'll come back and we'll hit the 2.2 video and see how we do on that. So good luck, everybody, and I'll see you at the next video.